Have you ever noticed that sad memories tend to come much easier when you're feeling sad? Or have you ever wondered why some memories can bring back intense feelings of joy? Or on the flip side, intense feelings of fear and sadness? Hi, I'm Richard and I'm going to introduce you to memory and emotion. Today we'll briefly explore the brain regions associated with memory and emotions, what memory is and how it works, and a role of mood and emotion in memory. Without memory, life as we know it wouldn't be possible at all. Everything we encounter would be new, and we would constantly be surprised or terrified at everything in the world around us. To learn where memories and emotions come from, we need to go deep into the brain to a complex anatomical structure known as the limbic system. There are many functions and structures associated with this system, but the two we are looking at today are the amygdala and the hippocampus. This long little structure here is called the hippocampus and is responsible for many aspects of memory, including the formation and remembering of memories. This little almond-shaped piece next to the hippocampus is the amygdala. This is the emotional control center of the body, responsible for emotions and mood regulation. Memory is just one of the brain's many cognitive processes. Cognition is a series of mental processes that help us to understand the world that we live in, and these include attention, perception, learning, memory, language, problem solving, reasoning, and thinking. Many cognitive functions are based here in the prefrontal cortex, which is commonly referred to as the rational brain, and plays a role in the regulation of the limbic system. So that's the wheres, but what's the hows? Let's turn to memory first. Three basic processes of memory and learning are encoding, storage, and retrieval. That is, memories are created and kept somewhere in your brain, and then remembered later on. But where are memories stored? The simplest and most well-known theory of memory is the multi-store memory model. According to this, we have three distinct places in which memory is stored: a sensory store, a short-term store, and a long-term store. The sensory store is the first, and contains all the information we receive from the world around us. What we see, we hear, we feel, we taste. Only if attention is paid to a particular item in this store will this information make it a short-term store. Short-term memory storage has an extremely limited capacity, allowing around 7 pieces of information at any one time. If we stop paying attention to a stimulus before it can be encoded into the long-term memory, or we get distracted, that information is lost forever. The long-term memory store is what we typically think of when we talk about memory. This information has been stored potentially for the rest of our lives, and when we retrieve this information, it is pulled back into the short-term store. However, much more recent research has shown that this model is a bit simplistic. First off, how do we use information stored in memory to actually make use of it? In 1974, the concept of short-term store was effectively replaced with that of working memory. Working memory is the part of the memory system that allows us to mentally manipulate the information that is held in short-term memory. Working memory is active and complex, consisting of more than just short-term memory. It is a central point for various cognitive activities, planning, problem solving, and decision making. We use knowledge from the environment and our long-term memory. Mentally calculating what time you need to leave the house in order to meet up with your friend at a cafe is thanks in most part to working memory. It is now widely accepted that long-term memory has more than one store. There are two broad classes of memory: declarative and non-declarative memory. Declarative memory refers to explicit or conscious memories that typically come to mind when we're thinking about memory. And these can be further broken down into personal experiences or episodic memory and general knowledge, semantic memory. Non-declarative memory is implicit or unconscious and includes things like automated responses, scripts of how to do things, and our skills and expertise. Declarative memory is closely linked to the hippocampus, meaning that changes there are likely to cause explicit memory loss, as we typically see in amnesia and mental health disorders. One very important thing to keep in mind about memory is that it is not concrete. Our experiences are not stored in our memory as if recorded from a video camera. Rather, memory is reconstructive. We encode memory rather abstractly, with elements stored separately from each other. Often, details are general, not specific. Retrieval cues, or information from the environment, are what we use to aid in the remembering of information stored in long-term memory. Every time a particular memory is retrieved, it is recreated all over again, and sometimes we can leave things out, or we can change certain parts of the memory based on new information or biases. This is real-world consequences, as this is what makes eyewitness testimonies in law so unreliable. Our emotions can also influence and change our memories. Emotion is a core part to being human. However, there is no consensus on how it is defined. We all know what emotions are for us: happiness, sadness, fear, surprise, and so on. But it can basically be understood as a brief physiological response related to thoughts and feelings. There is a strong link between emotion and memory, with the brain's emotional centre, the amygdala, playing a role in memory encoding and retrieval. Due to the strong connection between the hippocampus and the amygdala, the brain doesn't have to dig as far for emotionally charged information. Generally speaking, the more emotional a memory is, the more likely it is going to be retrieved. This is why traumatic experiences, or the happiest days of our lives, tend to stick with us. Several theories demonstrate how emotions and moods interact with and affect our memories. The mood state dependent memory model posits that memory is better when an individual's mood state at retrieval matches, rather than mismatches, that at learning. Mood is related to emotion, but lasts longer and is typically more stable, often lasting hours, days, and weeks. People are more likely to retrieve a memory when they are in a positive mood if they were happy when they made that memory in the first place. This effect is more prominent for positive than negative moods, though it is significant in both cases. Mood state dependency was demonstrated in Keneally's experiment. In this experiment, participants were asked to look at a map and remember a series of directions around the map. The next day, they were asked to recall as many of these steps as possible. In the mood congruent, or mood matching states, those who were happy at both the learning and the remembering stages were accurate 92% of the time, and those who were sad at both stages were accurate 87% of the time. However, when moods were different, those sad at recall were 71% accurate and those happy at recall were only 66% accurate. This effect was only reported in free and not cued recall, suggesting that mood may not always be a factor when we are directly reminded about something. The effect seen in the mood state dependent memory is the result of the specificity principle, which states that as mood is packaged with memories during learning, an overlap between retrieval information and information in our memory will be greater when the moods match. Another way that negative mood can affect memory is through memory biases. This can be seen particularly in mental health disorders such as anxiety and depression. Memory biases in those of depression start off with impaired cognitive control associated with the disorder. Attention difficulties mean we have an inability to avoid fixating on those negative thoughts in our heads. This in turn reinforces those negative thoughts, often about ourselves, leading to unconscious memory biases. By only focusing on the bad, it is hard to see anything but the bad. This can create a sort of self-fulfilling prophecy and is a tough hole to get out of. So why is the relationship between emotions and memory so important for us to understand? Firstly, it helps in learning. By understanding the optimal moods to study and train in, we can help boost our memory. But understanding this connection is important to help us when things go wrong as well. There is overwhelming evidence which demonstrates that memory is significantly impaired in a whole range of mental health disorders, such as depression, post-traumatic stress disorder, and anxiety. While many different mechanisms are involved in each of these, working memory is often impaired, leading to reduced attention and difficulty maintaining retrieved memories. Physical changes to the hippocampus and amygdala, particularly in depression, makes memory weaker and negative moods stronger. Negative moods can make it hard for these people to remember to respond to your text messages, to take medication, to go to the doctor, and even they forget to eat. So if you have someone in your life who is dealing with mental ill health, it is important to be aware of the effects of memory loss because they aren't often talked about, and to be more patient and supportive when it comes to these things. The best way to improve memory is to treat the mental health disorder itself, with memory tending to return to normal functioning following recovery. Anyway, that is all for today. I hope you all took something out of this video. Please give it a like below and drop a comment if you have anything to say or if you want to know more. Thank you for watching.